The word tsunami is Japanese for harbor wave, a deceptively gentle name for one of the planet's most unstoppable forces. But these aren't the waves you see surfers riding. While a typical ocean wave is a surface-level event whipped up by the wind, a tsunami is a different beast entirely. It's a colossal displacement of the entire water column, from the dark seafloor all the way to the surface, a true monster born from the raw power of the Earth itself. So what unleashes this power, and how can we survive it? Today, we're diving deep into the science of giant waves. The vast majority of tsunamis are triggered by immense underwater earthquakes, specifically what are known as megathrust earthquakes. These happen at subduction zones, where one tectonic plate is grinding and sliding beneath another. Over decades, even centuries, immense stress builds up along these fault lines. When that stress is suddenly released, the seafloor can lurch vertically by several meters in an instant. Imagine lifting or dropping a section of the ocean floor the size of a city. This motion displaces a truly massive volume of water above it. Gravity then takes over, pulling this mound of water back down, and in the process, sending a series of powerful waves radiating outwards in all directions. Generally, an earthquake needs to be over a magnitude of 7.0 and occur less than 100 kilometers below the surface to have the potential to generate a significant tsunami. But earthquakes aren't the only culprit. Volcanic eruptions can be just as devastating. Take the infamous 1883 eruption of Krakatoa in Indonesia. The volcanic collapse and massive explosions generated waves up to 135 feet high, a catastrophe that claimed over 36,000 lives. Similarly, underwater landslides can trigger these waves. These can be caused by earthquakes shaking loose, unstable sediment on steep submarine slopes. A truly terrifying example of this occurred in Lituya Bay, Alaska, back in 1958. An earthquake caused a massive rock slide to crash into the bay, which generated the tallest wave ever recorded, a staggering one, 719 feet high. It scraped trees and soil clean off the surrounding mountainsides. Once a tsunami is born, it begins its silent, high-speed journey across the open ocean. And here's a deceptive fact. In the deep ocean, a tsunami might be less than a meter high. Its immense energy is distributed throughout the entire depth of the water, which can be thousands of meters deep. With wavelengths stretching for hundreds of kilometers, a ship in the open sea could pass right over a tsunami and not even notice it. But what they lack in height, they make up for in speed. A tsunami's velocity is directly tied to the water's depth. In the deep Pacific, where the average depth is around 4,000 meters, a tsunami can travel at speeds over 800 kilometers per hour, easily keeping pace with a commercial jetliner. This incredible speed allows them to cross entire ocean basins in less than a day. The 2004 Indian Ocean tsunami, for example, caused devastation in 17 countries, with some waves reaching the coast of Africa, thousands of kilometers away from the epicenter near Indonesia. They can travel so far because, due to their incredibly long wavelength, they lose very little energy as they move. The real transformation, the moment the silent traveler becomes a coastal destroyer, happens as it approaches land. This process is called wave shoaling. As the ocean floor gets shallower near the coast, the front of the tsunami wave starts to slow down due to friction. But the back of the wave, still in deeper water, is traveling much faster and begins to catch up. This causes the wave's energy to compress into a smaller space. The wavelength shortens dramatically, and all that energy has to go somewhere, upwards. A wave that was just a meter high in the deep ocean can rapidly grow to tens of meters as it roars ashore. The specific shape of the coastline, like bays and harbors, can funnel and amplify this effect even further, which is where the term harbor wave comes from. A tsunami doesn't always look like a classic giant curling wave. It might arrive as a rapidly rising tide that just keeps coming, or a turbulent, churning wall of water called a bore. In some cases, the trough of the wave arrives first. This causes a phenomenon known as drawback, where the ocean suddenly and dramatically recedes, exposing the seafloor, reefs, and stranded fish. This is one of nature's most crucial and dangerous warning signs. It's an eerie, tempting sight, but it means the crest of the wave is right behind it and will rush in with terrifying force. The destruction is caused by two things: the sheer force of the inundation, the water rushing inland, and the powerful outflow as it all rushes back to sea. The force of the water can carry cars, pieces of buildings, and trees, turning them into battering rams. The receding water is just as deadly, dragging debris and people back out into the ocean. So how do you survive something so powerful? The key is knowing the warnings and having a plan. Warnings come in two forms: official and natural. Official warnings are issued by agencies like the Pacific Tsunami Warning Center. They use a network of seismographs to detect earthquakes and special deep ocean buoys called dart buoys to confirm if a tsunami has actually been generated. These buoys measure pressure changes in the water column and transmit data in real time. When a threat is confirmed, alerts are sent out through TV, radio, and mobile alerts. These alerts are categorized. A tsunami warning means a dangerous tsunami is imminent and you should evacuate. An advisory means strong currents are expected, so you should stay out of the water. A watch means a tsunami is possible, so be prepared. And an information statement means an earthquake occurred, but there's no tsunami threat. But for tsunamis generated by a nearby earthquake, there might not be time for an official warning. That's when you must rely on natural warnings. First, if you are in a coastal area and feel an earthquake so strong it's difficult to stand, that itself is your tsunami warning. Don't wait. Second, listen for a loud, unusual ocean roar, sometimes described as sounding like a train or a jet engine. And third, if you see that sudden, dramatic withdrawal of the sea, the drawback, you need to move immediately. If you get a warning, official or natural, the rule is simple: evacuate immediately to high ground and inland. Your target is to get at least 100 feet above sea level or 1 to 2 miles inland. If you can, evacuate on foot. Roads can become congested or be destroyed. If you're trapped and can't get to high ground, find a sturdy, multi-story, reinforced concrete building and go to the highest floor possible. As an absolute last resort, climb a strong tree. If you're caught in the water, grab onto anything that floats. It's critical to remember that a tsunami is not a single wave, but a series of waves, and the first one is often not the largest. You must stay away from the coast until authorities officially declare it is safe to return, which could be many hours. After the waves pass, the recovery is a long and painful process. The environmental damage is immense, with saltwater contaminating farmland and drinking water and coastal ecosystems being destroyed. The human cost is even greater, with communities shattered and economies crippled. But these tragedies have driven major advancements in our defenses. Today, our warning systems are more sophisticated than ever. Dart buoys and advanced computer models can forecast a tsunami's path, arrival time, and potential height with increasing accuracy. Researchers are even using artificial intelligence to analyze seismic data faster than humanly possible. Beyond technology, mitigation involves smart coastal engineering like seawalls, but also land use planning that preserves natural buffers like mangrove forests. And most importantly, public education and regular evacuation drills are proven to be the most effective ways to save lives. History has taught us these lessons the hard way. The 1755 Lisbon tsunami forced Enlightenment thinkers to grapple with the power of nature. The 2004 Indian Ocean tsunami, which killed around 230,000 people, led to the creation of a modern warning system for that region. And the 2011 Japan tsunami showed us the cascading effects of such a disaster, leading to a global re-evaluation of nuclear power plant safety. Tsunamis are an inevitable part of living on our dynamic planet. We cannot stop them, but we can understand them, respect their power, and prepare for them. Knowledge is our greatest defense. By understanding the signs, having an evacuation plan, and acting decisively, we can turn vulnerability into resilience and survive the unstoppable force of the ocean.